Welcome to the Financial Compass e-learning series. This session will explain the present value concepts that are the basis for rate-shocked net economic value, or NEV, in the interest rate risk section of Compass. Present value calculations are based upon the theory of the time value of money. This method is also referred to as discounted cash flow analysis. In its simplest form, the time value of money states that $1 today is worth more than $1 in the future. These timing differences become more and more significant as the dollar amounts increase. The math used to calculate this shrinking value may look complicated, but it's actually pretty easy to understand once you break down the parts. Economic value calculations use the same formula as the present value calculations in corporate finance. In fact, it's the same formula that's used for calculating compound interest. Let's look at the details. PV stands for present value. That's the value today of cash returned in the future. FV is the future value, or the amount of cash at the future date. R is the interest rate, or the rate of interest required by the market for this type of investment. And N is the number of time periods until the future value is received. An important detail here is that if the time period can be in days or months or years, but the interest rate needs to be for the same amount of time. So for example, if you're doing daily, the rate for a day is the annual interest rate divided by 365 or 366 in case of a leap year. And the rate for the month is the annual rate divided by 12. So let's take a look at an example to see how this compound interest formula really works. Let's say that we want to set aside some cash for a future vacation and we know it will cost $1,000. But you don't have to deposit the full $1,000 because you don't have to pay until you leave on vacation a year from now. Instead, you could buy a CD that will mature in a year. How much cash do you need to deposit today if the credit union will pay you 5% interest? Yeah, I know it's a high rate, but just bear with me. So now we'll go ahead and put these numbers in the formula. The future value is $1,000. That's what we need to pay in the future time. The R, or the interest rate, is 0.05. And the N is 1 year. Now we'll do the math. We can simplify this equation to PV equals 1,000 divided by 1.05. If we divide that, $952.38. But what if we had 2 years before vacation? Well, we'll just change the 1 in our formula here to a 2. And that's what's called an exponent. An exponent of 2 means that we multiply 1.05 times itself. The effect of compounding is that the divisor is not just 1/10 as it would be if we simply doubled the rate. It's 1.1025. That little extra addition there is the impact of compounding interest. That's the process of earning interest on not just the principal, but the interest that's reinvested at the end of each time period. The result is, if we do this math, that we only have to invest $907.03 to get $1,000 after 2 years. And that's a couple of bucks less than if the interest weren't compounded. Now here's a chart that shows the present value, or the amount of investment needed as time gets longer. And as you can see, that amount declines as the number of years until repayment increases. So the first basic fact that we know about present value is that the longer the maturity, the lower the present value. But also notice that this decline in present value isn't really linear. It drops a lot more quickly in the earlier years than in the later years. And eventually, as time goes on, this annual decrease becomes so small that it's lost in rounding. So now let's look at how the interest rate affects this present value. We'll add some other interest rates to this chart and see what happens. Well, that's really a big difference. So this leads us to the second basic fact about present value, and that is that the higher the interest rate, the lower the present value. Now, the other interesting thing that you can notice about this graph is how quickly the present value declines to almost zero when the rates are really, really high. In other words, the higher the rate, the faster that present value drops. Also, they all hit the bottom at some point. So at very high interest rates, there's little or no impact of extending the maturity to a longer term. At first it doesn't seem logical, but the fact is that just the cash flow from the interest payments becomes sufficient to provide an adequate return to the investor. And there's one more line on the graph that we should look at. That's the red line at the top. That's for zero interest rate. The zero line is flat at the exact point of the present value regardless of maturity. So in other words, there isn't any discounting that's going on. The present value is equal to the future value. That's actually consistent with the math formula that we use, and it does kind of make common sense. If there's no interest rate, technically it makes no difference when the cash flow occurs. Understanding all of these facts about present value should make it a lot easier to understand and evaluate the net economic value results in Financial Compass. For more information on net economic value, or NEV, take a look at that e-learning series video. And you can always get help by giving us a call at 800-323-3281 or by using any of the links shown. And thanks for being a PlanSmith client.